Virtual reality, or VR, has been hailed as the next paradigm for gaming and immersion ever since it rolled out, then rolled over back in the late 90s, with early implementations like Sony's Glasstron being described by John Carmack as like looking through toilet paper tubes. Fast forward to 2016 though, and the tech was awesome, but it still had a big problem: the price. Because on top of the headset, gamers in particular needed to shell out for much more powerful hardware than they would need to play the same game in flat mode. But there's some good news. Since that time, Oculus, who sponsored this video, has dropped the price of the Rift and continued development on some pretty neat invisible mechanisms that work in the background to make VR run on even relatively modest machines. And we spent the last week testing to see just how modest a machine you can use. And I think you'll be surprised. Let's begin with some of the efficiency improvements that are handled by your graphics card. Because in theory, every frame of an image in VR needs to be rendered twice, once for each eye. So technologies like NVIDIA's single pass stereo make it so your PC only needs to set up the scene's geometry once, and their lens matched shading actually cuts off any pixels which would not be visible anyway due to how the lenses in the headset work. Pretty neat. Then we've got the headset specific tech, like Oculus's asynchronous time warp and space warp, which kick in anytime your machine can't maintain the steady 90 frames per second that's required to prevent motion sickness by generating synthetic preemptive frames that act like a sort of suspension mechanism to smooth out the low FPS bumps. Getting this tech working right was quite a bit of work because GPUs are designed for high throughput, but not preemptive frame guessing. So Oculus worked with both GPU manufacturers as part of NVIDIA's VRWorks and AMD's Liquid VR initiatives. So it's more than a catchy slogan. Now let's introduce our bare minimum system. So we paired, where is it? Here it is. A Core i3 8100 quad-core processor and a GTX 1050 Ti and ran FutureMark's VRMark, which has a neat feature. Both the Rift's minimum and VR-ready performance requirements are baked into the results graph. And what we found was that even our bottom of the barrel actually managed to meet the minimum spec bar. So there you go. Video done, peace out, right? No, wrong. So upon further analysis, we actually found that while our rig was outputting 90 frames per second in the basic orange benchmark, which matches up with the refresh rate of the head-mounted displays in the Rift, the actual target is 109 frames per second. This is because aside from the graphics going on the screen, in VR, the system also needs to read sensors and do a bunch of stuff in the background. So with the overhead of VR, the calculation is that 109 frames per second in flat mode should correspond to 90 frames per second in VR. And Superposition basically said the same thing. So that setup was only good enough for like the very barest minimum spec. So we do need to go a little higher, but do we go for CPU or GPU? Well, we were watching our CPU load pattern during the runs, and our processor, even though it's a measly Core i3, well, it is a quad core and it didn't look that busy. So we bumped our graphics up to a GTX 1060 to see where that would get us. Usually people would pair such a card with an i5 class chip, but we're focusing on VR here, and even with all the trickery, it is still mostly GPU bound. And check this out. So it turns out that i3 plus 1060 combo here actually looks good to go with a super rating in VRMark Orange Room and a full bar in Superposition's optimum preset. So that puts our total system cost at just over $900 US. And bear in mind that that is including the Windows 10 home operating system, which Microsoft recently jacked up to $140. So if you already have Windows or whatever, then, well, you can subtract that. Of course though, those are synthetics. So the next step is to go lab rat mode and put this to the test. Now, normally I game in VR at home on a GTX 980 Ti, so I will be able to tell the difference if this doesn't manage to stay as smooth. So let's fire up the Oculus Performance Profiler Analysis tool and head-up display, which should help us pinpoint the cause of any frame rate drops that we experience. Oh, cool. Okay. So this is Oculus's redesigned home interface thing. Now you've got this control panel here that you can move to wherever it is that you want it to go. And then you can go ahead and decide, well, you know, which menu do you want to see? Oh, I can close them. So there's my library. There's my Explore tab here. And then you can kind of adjust this one over here. Oh, neat, you can interact with the desktop as well. Oh, that's trippy. Let's go ahead and look at the other monitor, the one that's not capturing my experience right now. Ah, yes. Hey, you can mess with Ivan. Hey, Ivan, I am opening your start menu. What are you gonna do about it?
I can touch you inappropriately.
Oh wait, I probably shouldn't open Fraps. Oh, that just glitched it out. I don't know what this thing is. Yeah, thank you. Let's get, are your monitors different sizes?
Yep, one is 4K, one is 1080.
Dang it, Ivan. Game now, right?
Walk around the place somewhat, because see, they made it social, so you can invite people to come over to your virtual home.
Friends, currently 0 friends online. Thanks, that's why you wanted me to open that, isn't it? All right, what's next?
Play some Robo Recall? You've played this game before, haven't you?
I've played VR shooters. Dang it. Yeah, it's really fun. All right, well, I think that's good. I think that's all the evidence I need. This is working awesome. So for our last trick, we're trying out the climb, kind of the crisis of VR, if you think about it that way. Like the graphics in this game are, especially when it was first released, are pretty incredible compared to what else there is. Now what? I just, oh, that's a long way to fall. Huh.
This is maximum settings too. Eh?
Yeah? Ooh, go, 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 go. Look at me, I'm like Superman. Superman. Oh, wait, did it? Oh, well, Superman falls sometimes. Okay, so actually that went surprisingly well, but still the point remains that in a massive surprise to no one, just because a benchmark gives you a good score and you can run many VR games well on a relatively inexpensive budget, does not automatically mean that you can run any game maxed out in VR. It's, I mean, same idea as in flat mode, right? So just like flat mode, if you do have some more budget and you're buying a VR gaming rig, it wouldn't be a terrible idea to bump your specs a little if you want to play VR versions of flat games like Fallout 4 and Skyrim, since VR is more demanding. But frankly, I've actually found that the most fun that I've had is in games that were designed for VR. And what's cool is that the climb, in my opinion, is more of a tech demo than an actual game, and that one still ran decently. And most of the VR games out there that I've tried, some of which are good and free, like Robo Recall, are not nearly as demanding because it's in the developer's best interest to reach as many customers as possible with their games. So our PC, right here, and of course we're not factoring in some of the RGB nonsense and stuff like that in our cost for it, but our PC here can enable a ton of awesome VR experiences exactly the way it is. So thanks to you guys for watching. Thanks to Oculus for sponsoring this video. If you guys disliked this video, you can hit that button. But if you liked it, hit like, get subscribed, or maybe consider checking out where to buy the stuff we featured at the link in the video description. Also down there is our merch store, which has cool shirts like, is anyone wearing an LTT shirt? No one? Where's your team spirit? Like the LTT shirts that we have, and also our community forum, which you should totally join.